Hi Pablo, so we're going to start off with question 1. And question 1 asks to explain the high-level steps of the unsharp masking process and why does it sharpen an image. The process of unsharp masking begins with an original image like this one. In order to move forward, you first want to receive a blurred version of that image. As you can see here, the blurred image is what we see now. Images can be broken down into values representing individual pieces of the picture, which are called pixels. Both of these images are made up of values in a grid, like the one I'm about to show you. So both images have their own grid, and the grid of values for the blurred image came directly from the original image's grid. The blurred image was once the original image, and was created by altering each pixel in the original based on its surrounding pixel's weight. The next step in the unsharp masking process is to go through each grid value by value and subtract the blurred image values from the original. This will leave you with an image composed of only the sharp features, which are the parts of the grid with high values. This image here is an example of the sharp values from the original image. So now the next step is to go through the original image's grid and alter those values by some factor. The scaling factor tells how much to sharpen an image. Here is an example of the scaling process on the original image with a value of 0.7. Finally, the sharp image is placed on top of the original image, which has been altered by the scaling factor, as we just saw, and this will result in the sharp version of the image, as you can see on the screen right now. Okay, so now it's time to move on to question 7. So question 7 asks us to explain how you do input checking on each of the 3 methods that we were assigned. And explain the different checks that we did in all the scale array method, the blur window method, and the add rectangle method. So the first thing that we were told to check for was that factor was in bounds. Factor should not be less than or equal to 0 or greater than 1. So that first if statement there says if factor is less than or equal to 0 or factor is greater than 1, to return the original array and stop the method. The array method is that the double array A, which was the input for this method, is not empty. So what we can do for that is just initially check if A is null, which means that is A empty, and if it is, then we're going to return. And we're just returning null here because the integer double array is an output, so we need to have an output here. And just to double check, we're going to check the index of 0 for A to see if that's null, and if that is null, then we know that the array is in fact empty. So now let's move on to the blur window method to do those checks. Okay, so the first thing that we're going to check in the blur window array is that the input array kernel, which is a double array with a double type, is not empty. So the first check that we do is if kernel equals null, which is just saying if kernel is null, then return and stop the method. And we don't have to put anything next to the return because the return type in this case is void, so we don't actually have to return anything. And just to make sure that kernel is in fact empty, we check the first index, which is at 0, and say that if kernel sub 0 is null, then return, because if there is nothing in the 0 index in kernel, then the rest of the array is definitely empty. Window array. The last thing that we just have to check is window array, which we are using in this method. And we just have to make sure that the window array is not empty as well. So we first do the initial null check of just the entire array, and if it is null, then we return. And then just to double check, we check that window array sub 0, so that first index is not null as well. And if it is, then we're going to return. That's the entire blur window array. So now we're going to move on to add rectangle. Okay, so there are many more checks that we have to do for this one that we didn't have to do in the last ones, but let's start off with the simple one that we've done in the past 2 methods, which is just checking that the initial array, or window array in this case, is not null or not empty. So we're going to do our null check for the entire array and return if it is null. And just to double check, we're going to do the null check for the very first instance of the array, or at index 0, and we're going to return if that is empty. The next thing we want to do for this method is check that iStart plus tile height is not greater than the length of window array. So because we're creating a rectangle inside of the initial array, we want to make sure that I start, which is our starting position for the row, and the tile height do not exceed the length of the array. And if they do, then we're going to return. The next check is very similar to our last one, but instead of worrying about I start and tile height, we're doing J start and tile width, and we're making sure that it's not longer than the first index of window array. So that first column size, we're making sure it starts at J start, and we're adding tile width, and that's going to ensure that we are not having a rectangle with a greater width than the window array can hold. Next, we were told to check that the line thickness is not less than 1 or greater than 10. And in this case, if it is less than 1 or it is greater than 10, we're going to return. So that's just that check there. So the last thing that we're going to check for this method does not actually have anything to do with returning the method early, and it's just seeing if the color should be white or black. So we're saying if the color is light, then make the color 255, which is white, and if it isn't, then make the color equal to 0, which is black. That was all for question 7, so now let's move on to question 8. For this one, the question asks, how does the unsharp masking process change when you vary the scaling factor in the range of 0 to 1? So in the scale array method, we're given a scaling factor of 0.7 to alter the individual indices of the original 2D array. Each integer in the array represents a different lumosity, between 0 and 255. 0 being the absence of color and black, and 255 being white. If we were to alter the scaling factor, say to something like 0.2, we would be left with much lower numbers than we had before, leading to a much darker image in the end. The scale factor tells you how much to sharpen an image, and with the scale factor of 0.2, the image is not going to be sharpened very much. Scale factor of 0.9, your resulting array is going to be left with much higher values than a scale factor of 0.2, which tells you that the image should be sharpened a lot more than the 0.2. So a sharper image rather than a less sharp image. A scale factor is basically like a weight that influences how much to sharpen an image, or the original image. And a higher scale factor will create a sharper image than a lower scale factor. And that concludes my final project. Thank you so much for listening, and I really enjoyed this semester, and I hope you have the best holiday season ever.